Okay, well, welcome to the fourth part and last in the series with my home apply cluster. You probably would notice that it's been a while since the last video. I left off basically with some problems with K3S. Um, I've since done a lot of work and learned a lot, and that was the whole goal. I wanted to get some experience with Kubernetes and clustering and setting up my own home cluster. And yep, heck, did I learn a lot. So I also had a separate thing where I was using Git to uh, have all my changes in code stored. So this is my GitHub page with my Bramble cluster and my notes. So primary goals were Plex for media streaming, Sonar for TV, Radar for movies. These are for getting TV shows and movies. Jacket for torrent indexing. One thing I missed on here was, actually, no, I didn't. NZB Get is the news reader to feed Sonar and Radar, the TV and movie searching. And a big requirement was to have a VPN tunnel running my torrent client. That was a big deal that I wanted to make sure I had working. Stretch goals was to automate as much as possible. I used Ansible. I wanted to have a Pi-hole DNS blocking container working. I wanted some container metrics or metrics for monitoring. I ended up using a thing called Omni. I wanted a dashboard for the cluster, and I wanted to use some persistent storage. And I used Longhorn and CIFS, which is pretty cool. All right. So I've committed all my code. It's not the best, but it'll work. I learned a lot with Git as well. And well, let's get into it. So the first step was basically just to doing an installation of actually the OS for the Raspberry Pis. So to do that was basically I used 64-bit Ubuntu OS on the Pis. Since then, the Raspberry Pi Foundation has come up with their Raspbian 64-bit OS. I don't plan to go back and redo everything with that. And anyway, basically, I used Ansible to do a installation of all the things I wanted. It would get all the package updates, apply some various fixes for DNS resolving. There's an important group setting for C group settings for the Raspberry Pis. You need to have that enabled, or you'll get errors when you run K3S or any Kubernetes, because it needs those compute groups or some memory group settings on the needs basically. And some various other things, updates the host name. I disable the unified firewall service because I don't really need it. And some other, yeah, so let's just I'll do the test run of so basically what this is running is just an Ansible playbook with my setup Ubuntu playbook, along with all the hosts in this host file with the username, and -- check is just doing a check. It doesn't actually do anything. So it's first of all, it's just going to do a test run and see what it does, and it shouldn't come back with not needing to do anything because there's nothing for it to do. Some other things that the playbook does is that it installs a thing called Keep Alive D, and Keep Alive D will let you assign a floating IP address to all of the 3 or more nodes that you have, that lets you then have one IP that you can manage through. Because if you don't, then when you're running your management system, which what I'm doing is I'm not managing the nodes on each node themselves. I have the authentication key for Kubernetes running on my a separate Linux for Windows subsystem for Linux, and it connects to the cluster to do the management tasks. I find it much cleaner to do it that way, but then one issue is that if one of your nodes that you're using in your file to manage your, if you're managing through here Windows subsystem for Linux, and it's configured to go to one node, if that node goes down, then it's going to, you're not going to be able to get to the other node. So that was the reason I put the floating IP on there with keep alive D. It doesn't work as great as I thought it was going to do. It's quite slow. I must be missing something with the keep alive D. Basically, this is my RPi1, which is what I called it. I just wanted to, if you do a, oops. There we go. There we go. So IP brief address show on ETH0, you can see that it has one IP at this primary, but then this other one, 240, is what I used for the floating IP. So it actually, you can actually ping that, and it does work. Oh, that's interesting. Not quite sure why the second pi timed out. Obviously something happened, couldn't connect or something like that. Well, that's okay. We don't. This is just a demo, so you can see the playbook is checking. It's doing a few things, installing. There's one thing where you're installing prerequisites, making sure that all the updates are ready. Install any required updates. There are none. I had problems with Snap. I got rid of Snap. It's another way to install packages. I just am relying on the Ubuntu repository, so I didn't want to mess around with Snap. It can be useful, but anyway, I think what's happening is that there are some updates, and that's why it's taking so long. Anyway, so let's keep moving on. Actually, I think I'll just cancel out of that. We don't actually need to finish that one. So there are some interesting commands that you can run with Ansible. That's nice because you can, if you have only one host, it's quite easy to manage. But if you have more than one, being able to do the same repeatable set of instructions across a bunch of systems at once is very handy. One thing that I find useful is the ping command. You can ping all the hosts in your cluster. Oh. So that's why. Apparently Raspberry Pi 2 is unreachable. That's interesting. Well, let me just doing it live, I guess. Let's see if I can even log into Raspberry Pi 2. All right, I can. So not like it's not working, so must be just a transient thing. Let's try to ping again. Maybe it was just it was busy. I do note that with the Pi cluster, it can get busy and it is sometimes not very responsive, and you just have to try again. As good as the Pis are, they're not a workstation class, and they can be a bit slow sometimes. So patience is good. Another good thing is you can actually reboot all the hosts as needed. I'm not going to do that right now, but anyway, one thing that's really good is I've set up USB sticks on each Raspberry Pi for persistent storage. So if I do a mount, I've also done this with Ansible, but actually no, I didn't use Ansible to do this. Now there's a lot of things to mount here. Maybe I have to grab 4. Let's Okay, anyway, lots of things are mounted. There's 64 gig USB sticks mounted on the SDA drive device, and I use that in the persistent storage later. So each Pi has the same amount of storage. Using a USB stick on each one, you don't need to. You can. They all have SD cards. You could all write to the SD cards. But I found that I haven't run into it yet, but a lot of people were saying that if you can reduce the number of write cycles on your SD card, which has your OS installed on it for your Pi cluster, you can extend the life of the SD cards. They have a finite life. You can only write so many times to it. I have good quality SD cards. I don't really want to be having to change them a lot. And I think I talked about this before, but anyway, this is one other step. So basically, there's a set in my installation guide where I format and get those things prepared. So now the big nuts and bolts is the Kubernetes K3s. I use the K3s project from Rancher because the mainstream Kubernetes for K8s, which is also what it's referred to, is too big for a Pi cluster. So the folks at Rancher stripped down everything from Kubernetes down to the bare minimum, and so they came up with a lightweight Kubernetes clustering system, K3s, that is really, really, you can do everything that you want to without all the overhead, which is really great. So I went ahead, and there's Ansible playbooks to do the installation. Let's see how long this hopefully this doesn't take as long as the other one. So this is just another check. Basically, I'm just checking to make sure K3s is installed. I did set it up where I install one node at a time. I don't install all the nodes at once because I found that it was just a bit easier to manage it that way. I'm sure you could set it up more automated, but anyway, I would install the first Pi, and then I'd make sure that's working, and install the second Pi, make sure that's working, etc., etc. So in this case, so it's also verifying if it is installed and don't if it is. So that's a good point, and that's all good. So once you do all that stuff, you basically want to see, well, what's actually happening. So now once all the K3s is installed on all the nodes, you can run the kubectl command, get the nodes, and you can see that all 3 nodes are up and they're checking in and they're all ready. Everything's good. So that's the end goal. You can also do a wide command. When you do wide, the text will wrap a little bit funny, but it shows a little bit more information. You can see the OS that it's running, the internal IP, what version of K3s you're running, what kernel version, and the container kernel version of K3s. Actually, no, sorry, it's the kernel version of the OS. Anyway, good stuff. I did use some packages on my workstation. I installed some things from Arcade. I mentioned this in a previous video. Arcade is a mixed bag of utilities to manage K3s. Some components work, some are too old. One that's really important that needs later is Helm. Helm charts let you install containers to your Kubernetes cluster, and the version on Arcade is too old. So anyway, I have instructions on installing Helm manually, and actually that's all cool. All right, let's get going. So Metal LB, sorry, this was the magic that allowed communication with resources that I was running on the cluster. There was I had a lot of trouble with basically the instructions online. It's very easy to get a container working on K3s. But then getting access to that container to see if actually it's working, and I mean working in that you can access it with a web browser, for example, it's pretty hard. So, and when I say hard, I mean there's a lot of conflicting information. You get documents about ingresses, you get documents about load balancers, you get documents about cloud provider load balancers. Anyway, basically, Metal Load Balancer lets you set up a bare metal load balancer on your small cluster that has a really it lets you assign it automatically take an IP address from a range you assign, and then it'll just work. So you can change your node type to cluster from cluster IP, which is part of the networking. You can change that to load balancer, and Metal Load Balancer will take care of all of the things about letting that run. And if you do a get services, if I spell it right. Oop. I need to say all. So this is the key. Like, I have a lot of stuff running here. Don't get confused. The cluster IP, without Metal Load Balancer running, all you'll have is cluster IPs assigned. These are internal networking. But with Metal Load Balancer, you'll start to be able to get external IPs assigned, and these IPs very easily map to the internal cluster IP, and it exposes your service way easier than setting up an ingress controller. I do have an ingress controller configured. I do use it for something. I use it for Pi-hole, the DNS. But anyway, I'm getting ahead of myself. So anyway, Metal Load Balancer is the way to go. Am I going to do? Well, let's try it. I have a test. Actually, no. This video is going to get too long if I go through all these things. Okay. Let's skip ahead. The other thing. Well, let's go to some things. So there's my GitHub page. Let's talk about persistent storage. Okay, graphical, nice graphs, nice graphical things. So for my persistent storage for the cluster, I used a project called Longhorn that lets you assign. These are the USB sticks that I have on each Pi. And since there's one per Pi, Longhorn will let you create persistent volumes that then span each cluster. So the data is replicated across each node. And you can see that from the dashboard. There's 3 nodes. They're all healthy. 6 volumes. It's just basically how many volumes are running here. And what it lets you do is that pods come and go. Containers come and go. So if you delete a container and it moves to another node, if you're just using local storage, that storage is tied to that particular node, and your node won't work. So some kind of persistent storage. Sorry, that's the other thing. When you normally create a node, any storage assigned to it is thrown away as well. So you need a way to, for some things, store data that's persistent. Some good examples are for my media components, I need to be able to store the configuration. I need to be able to store the database for the things that are running. Some things that I don't care about, though, are actually the DNS system, Pi-hole. That one I don't care about the data. It can be recreated and it'll just populate it again, so that's fine. Anyway, all 3 nodes are here. Pi-hole Longhorn is pretty great. It's pretty easy to set up. It might be a little bit more complicated than you might necessarily need, but I found it quite useful. Some things to note about Longhorn is that it doesn't auto scale. So when you're setting up your volumes, you need, well, sorry, I don't say it doesn't auto scale. It's difficult to auto scale. It's difficult to increase the storage size, at least from my perspective. Maybe I'm missing something, but anyway, it's better to get the amount of storage you want off configured to what it needs before moving on. I had problems with not having enough storage assigned for my TV system, for example, and it ran out. Anyway, so I assigned more. Other things you can do with Longhorn is you can actually set up backups, so you can actually back up data to an external source. You can actually set it up to backup to AWS S3, which is pretty cool, or just a regular NFS service. Anyway, but getting over top of my what I want to talk about. Okay, moving on. So that's Longhorn. I did a bunch of testing of Longhorn, making sure that when I created a volume, I could tear it down. There's actually also different. You need to. Anyway, I'm getting ahead of myself. Okay, so I also had a section of testing my cluster recovery. So I was killing some pods and making sure that they came back up again after some time, and that was good. So I spent a lot of time making sure that, well, let's move over to the Kubernetes dashboard. So one stretch goal was to have a dashboard, and the Kubernetes dashboard has a lot of, oh boy, I think my token expired, yeah. So one problem with, well, it's not a problem, but I haven't fixed this yet, was to get a new token for my dashboard. This is in the documentation. I just have to regenerate this token. I'm sure it's straightforward and easy, but I just never got into getting it persistent. So there we go. Just have to recreate the token. Okay. So it's pretty good. The Kubernetes standard dashboard, it gives you a lot of information. I won't get into what some of these things are, but these are the deployments, some of the services not services, some of the deployments I have running, some of the pods that are running, or all the pods that are running. I won't get into some of those things, but you can actually see under services, here are the services that I was talking about before with the external endpoints. And one of the ingresses that I was talking about that's only being used is Pi-hole. It's using an ingress instead. So anyway, the dashboard for Kubernetes is pretty good. There's a lot of information. It's kind of nice. So I've talked about Pi-hole. Let's go over to Pi-hole. And Pi-hole is pretty nice because it's a DNS ad blocker. It was one of the reasons I wanted to get a cluster working at home anyway, because I wanted to be able to run Pi-hole as my primary DNS, but have it reliable. So I didn't want only one DNS system running, because DNS is pretty important for your network. I wanted it to be reliable, so I wanted to have 3 nodes. One node goes down, Kubernetes will move that container to another working node, and it'll just keep working, right? It's also kind of neat that you can see the ad blocking part is pretty nice too. So it's pretty automatic. It doesn't block everything, but unlike a traditional ad blocker, there's no pop-up blockers. Detection can't help them. So basically it'll just show a blank area where the ad was, and you don't get bothered by a site saying, oh, disable your pop-up blocker to keep going through here. Anyway, you can get some data over time. So it's pretty nice to run Pi-hole, and it's a pretty good little service. But getting on to the main goal, though, the main goal of all of this was to run my home media over on the cluster and move it off of the system that I had. It was basically a Windows machine that's hooked up on my network. So that's the bread and butter here. Sonar, I won't go into all of the steps on setting all these things up, but if I go back to the cluster and I do a get pods, I have a thing called, there's a concept called media namespaces in Kubernetes that lets you pare down what returns back so you don't have a big list. So I have a namespace called media, and I get the services in media. You can see that I have various different things running here. There's the OpenVPN transmission system, and they're all exposed with metal LB. And then there's the internal ports. So it's pretty nice to be able to do all this stuff. It is a little bit slow, but Sonar lets you get TV shows. Radar is the same for movies. Jacket is a indexer for torrent, BitTorrent indexers on the internet. With Sonar and Radar, you need to set up indexers to tell it where to search for media. And I use, there's Jacket, that's this service here, and Usenet for this NZBGet. NZBGet is a news group downloader, and I use it primarily to get TV shows rather than torrents. The last thing is transmission is the torrent interface. It will only run over a VPN, so it's the traffic is encrypted. A note on media in general. Heather and I subscribe to several streaming services. So we have our media in various different places, but what I'm doing with this system is that it's nice to funnel it all into one spot instead of having to flip back and forth between different streaming services. So we pay for our media, but I like the convenience of being able to have it all in one spot. So that's what I'm doing here. The last thing, obviously, then is to show where it's actually coming down into, and that system is Plex. So if you log into Plex, all of that media that's being pulled down from those guys there show up into the categories here. So basically, this Plex is not running on the Raspberry Pi. I found that it was just too resource intensive. And talking about resource intensive, the last thing was basically monitoring. You can get some monitoring through the Kubernetes dashboard when you look at, I think the individual pods should have CPU and other metrics here, but you can't really show over time. Like it's just very, it's limited. So what I found was a project called, it was called Omni. I have all this documented on my installation notes, but Omni is a lightweight monitoring application it's written in Python. I tried to use Prometheus. I found that Prometheus would work for a day or two, and then it would basically crash on the Pi because it was just too resource intensive. Other people were saying the same thing on the internet. So anyway, what I found was here then I have CPU monitoring, memory monitoring. You can see that the third RPi3 is the one that's consistently high. It's because that's where all of the nodes, the pods that are running my media stuff are running. Same thing with memory use percentage should be all Pi 3 and disk use Pi 3. So it's the one that's the most used. Although, funny enough, Raspberry Pi 1 is the highest temperature-wise, which is a little bit funny. Anyway, that kind of wraps it up. I think that was the last thing I wanted to talk about. And yeah, so I have all this stored on my Git repository, and I learned a lot about Git. And I've covered all the goals here, and yeah, so looks good. So I'll stop here.